Hey everyone, and welcome back. We're going to be discussing the role-based access control in this video and leveraging OpenZeppelin's access control contract for that. So in the previous videos, we had essentially the ownable contracts, which assigned one single owner to control all the privileged functionality of any given contract. But essentially what it says here is that in essence, we will be defining multiple roles, each allowed to perform different sets of actions. So it's a way of adding more granular control and basically distributing privileges among multiple addresses. And down here before the little code snippet, it says its usage is straightforward. For each role that you want to define, you will create a new role identifier that is used to grant, revoke, and check if an account has that role. So here they're defining a minter role. So this is the ERC20 token, and the minter will be the address that's privileged and responsible for minting new tokens. And the standard way of doing this is to declare a bytes 32 variable and basically assign the value to the Ketchuk 256 hash of whatever the title of the role is. So in this case, it's minter role. We have another example down here where they have a minter and a burner role. So another way of distributing functionality and privileges rather between multiple addresses. And then the highlight here, limiting what each component of a system is able to do is known as principle of least privilege, and it's a good security practice. In other words, you don't want to give a single address more authority than it actually needs, and that's considered to be, of course, a good practice when you have any sort of complex functionality and sensitive functionality. So basically, by default, accounts with a role cannot grant it or revoke it from other accounts. So just because some address has the minter role doesn't mean you can automatically transfer that privilege to another address. Basically, that's just a way of passing the check for that role so that it could perform that functionality. But to actually grant and revoke roles dynamically, you will need an admin role of some sort. So each role, though, can have its own admin. So it doesn't necessarily mean you need one admin for the entire contract, entire set of roles. You can define separate admins for each role. So that's another way of making it more granular and thus inherently a little bit more secure, in the sense that you couldn't really have one address that goes rogue and can access all the privilege functionality of the entire contract. If one privileged address suddenly decided to go rogue, then at least it'll be limited to whatever scope of privilege that address initially had. So let's go ahead and jump in and look at the code here. Before we get started, though, one thing I need to mention up front is that there's a new dependency here, .env, so that's a way of managing environment variables. Hardhat recently, or I think somewhat recently, introduced a way to do that natively, but I'm just going to use .env just for simplicity. That way, if you decide to try these unit tests for yourself, you can simply go to the sample env file here, copy it, and then make your own .env, and just passing in a value for whatever RPC you're using. In this case, I'm going to be using Alchemy. They have a good free tier, and I'm not sponsored by them or anything, but just I like the way they make everything kind of simple and free to use for a certain period of time, or a certain quota, I should say. But there's lots of actually free RPCs out there just in general, so I'll post a link down below to where you can find just totally free ones in case you don't want to sign up for an Alchemy account or a Fora account or whatever it is. And also, if you decide not to do this, it's not going to break all the other tests. So you can see here, if this key is undefined, you can still run every other test that's going to be part of this repository. But now let's go ahead and jump into the actual contract here. So we can see in this access control, we have the modifiers only role. So it's checking that the address that's calling the function has that role before executing the code within it. You can also check if an account has a certain role, just if you're trying to find out which addresses have or don't have a certain role. You can get the admin role. You can also, and then admin can grant the role, and then of course the admin can revoke roles, or any address that has a certain role can just renounce it on their own if they don't, if that address for whatever reason doesn't want to have that privilege anymore. That's basically the overall functionality here. So for the example we're going to make today, we're going to go ahead and make just a simple contracts, relatively simple. That's going to be just a contract that's meant to handle deposits and withdrawals of ERC20 tokens. and also it has a pausable functionality as well. So we're going to have or I should say, a pauser role for this contract. And because we're going to be dealing with ERC20 token transfers, we're going to use the safe ERC 20 interface or contract rather, for the ERC20 interface. And this is another one of the OpenZeppelin utilities that you can use in your contracts. I should say four. Oops. There we go. And we're going to have a couple of events that we're emitting. So we're going to have an event for deposits. And we want to know the account that received or deposited funds. And we're going to have this indexed. Just good practice to have whatever relevant, important values that are being emitted by the event to be indexed. That way, if someone's listening to events on a blockchain, it'll be easier for them to kind of listen for those events or those values, or filter by them, I should say. And then we're going to have another address for the token. And then we're also going to have the amount. And then we're going to do pretty much the same style of event for withdrawals. We're also going to have one custom error here. We're going to call this insufficient funds in case someone tries to withdraw more funds than they have in their balance. And we're going to have our constructor here. Actually, we need our constant first to represent the pauser role. So we're going to have bytes 32 public constant pauser role. Once again, that's going to be equal to the hash of the string value pauser role. Now we can go ahead and make our constructor. So we want the address of the pauser. That's pretty much all we need to pass when we're first deploying the contract. We're going to make the deployer of the contract be the admin role. So we're going to say grant role. So we're just going to pass in default admin role here and make the contract deployer the admin. And now we'll go ahead and grant the pauser role also. I'll do the typo here. There we go. And then pauser. Okay. And actually, since we're handling the ERC20 token balances, we need a mapping for that. So we're going to map the account address to another mapping of tokens and balances. And let's go ahead and make this private and then just provide a getter function so that off-chain accounts can get just balances for individual addresses and tokens. Okay, now let's go ahead and begin defining the deposit function. So here we just need to have information about the token and how much they're depositing. Oops, that would be uint. Anyone should be able to call this function, but shouldn't be callable when the contract is paused. So we're going to use when not paused here. And then we're using the safe ERC20 contract for the ERC20 interface. So we'll just go ahead and cast the token to be ERC20. And then that should give us the under the hood methods provided in the safe ERC20 contract, which essentially are safe transfer methods. So basically what it's doing is making sure that if the transfer fails, the transaction is going to revert, which is actually not standard behavior for all ERC20 tokens, for example, with USDT. If the transfer fails, the function is still going to return like false or something, but it's not going to revert the transaction, which could be counterintuitive or problematic. So that's why this interface or safe ERC20 contract rather will handle that for us. So let's see here. Let's go ahead and pass in a message that sender is from. It's going to be to the contract address.this or address this, and then the amount. Okay, and then as long as this line executes without reverting, we can assume the transfer was successful. So now let's go ahead and update the balances. So here we have balances, and then pass in the account, so message.sender, and the token, and then incremented by the amount that was transferred. Actually, we can go ahead and emit the deposit event here as well already. Okay, that should basically be it for the deposit function. Now we'll go ahead and make the withdrawal. So the only difference is here we're going to add a receiver address in case the person or the account that holds the balance wants to transfer to some other address. Or withdraw it to some other address. Anyway, so here we go. Everything else will be the same. Once again, it's going to be external, and it's only when not paused. So here we got to check the balance first. So let's say if balance is sender for that token is less than the amount, then we're going to revert with our custom error. Otherwise, we'll go ahead and emit the withdrawal event. And then we'll go ahead and decrement. We'll go ahead and actually decrement the balance here first to prevent any sort of reentrancy vulnerabilities. So we always want to make sensitive state changes before doing any kind of transfers. So here we're going to say balances sender token decrement by the amount. Now we'll go ahead and make our transfer. So send to the receiver the amount requested. So I think this looks good. So we got check here, making sure they have enough balance, and then update the state first, then make the transfer, then we'll pass it in, emit the event. And then now we need the pause and unpause functionality. So here's where the pauser role will come into play. So we'll say pause, and external only pauser, or only role rather, excuse me, then pauser role. And then once again, we're just providing a wrapper around the pause functionality already provided to us in the pausable contract. So if the contract is already paused or something, like that is already being, it's already being handled essentially by the pausable contract we're inheriting from. Then we'll do the same thing for unpause. pause. And then lastly, let's make that getter function for the balances. So we'll say function balance. And here we just need to know the account and the token they're getting balance for. External view function, and it's going to return balance. Returns, not return. Oops. There we go. Okay, and then as long as we set this balance variable here, declared here in the return statement or returns portion of the declaration here, then it'll implicitly return that for the function. So we just go balance equals balances account, and then token, and then that'll automatically be returned from the function. Okay, so I think this looks okay. All right, so let's head on over now to the unit tests that I prepared ahead of time. So just going over what they are briefly here. So we got a couple of tests to make sure the roles are set properly when the contract is first deployed. We have the test to make sure the depositor can both pause and unpause the contract. Should be able to deposit wrapped Ethereum when not paused, but it's going to revert when it is paused. Same thing in regard to withdrawals. Also might as well test to make sure that the balance has to be sufficient, otherwise it's going to revert. And we should allow the deployer, in other words, the admin, to basically revoke the depositor's role. And also the depositor should be able to pronounce their role as well. And basically, yeah, the reason why we added to the config here, the forking the mainnet config, is that we're going to be using just wrapped Ethereum for these tests. We're going to fork the mainnet, and then we're going to be interacting with the wrapped Ethereum contract to run these tests. So basically, whenever there's a test involving depositing an ERC20 token, we're going to take the initial value of regular Ethereum that was given by the hard hat network to our account, just kind of automatically for testing purposes. We'll take it, take that, whatever it is, in this case 2 Ethereum, and we'll send it over to the wrapped Ethereum contract, calling the deposit method, and that'll return to us wrapped Ethereum that we can use for our tests. So let's go ahead and see what happens when we run them. All right, looks like they all passed. So yeah, if you want to go ahead and play around with it on your own, just check the description for the link. You can clone the repository, add log messages, or just play around with things, do whatever you want. But that's all for this one, and I'll see you guys in the next one.